NASA just went live. Their conclusion? 3I/ATLAS is just a comet. Case closed. But here's what they glossed over. A million-mile anti-tail piercing toward the sun, defying physics we've observed in every other comet. The largest non-gravitational acceleration shift ever recorded. Rotation affecting the Coma in ways never seen before. They showed fuzzy images, repeated "it's a comet" like a mantra, and avoided the hard questions. The data is public. The anomalies are real. So why the rush to declare it ordinary? Let's dive right in. So the moment finally arrived. After weeks of anticipation, NASA went live. And within the first 30 seconds, Amit Kshatriya made their position crystal clear. This object is a comet. It looks and behaves like a comet, and all evidence points to it being a comet. Firm. Definitive. Case closed. But then something interesting happened. He spent the next minute talking about how magical the universe is, how NASA actively searches for signs of life, how they just announced potential ancient life markers on Mars. Why open with that defensive posture if the science is so straightforward? The presentation rolled out exactly as you'd expect. Polished graphics, mission logos flashing across the screen. Nikki Fox proudly announced that nearly 20 mission teams coordinated observations. Hubble, James Webb, TESS, Perseverance, Maven, Lucy, Psyche, Parker Solar Probe. An unprecedented effort spanning the entire solar system. And yes, that is genuinely impressive. But here's the question nobody on that call seemed to ask. When was the last time NASA mobilized this level of resources for just a comet? We've seen two other interstellar objects pass through, Oumuamua and 2I/Borisov. Neither received this treatment. The images came next. The Mars Reconnaissance Orbiter's high-rise camera captured 3I/ATLAS from 19 million miles on October 2nd. What filled the screen? A fuzzy white ball. That's what months of tracking and billions in equipment delivered. A glowing blob. Now, to be fair, the angry astronaut predicted this exact outcome before the conference even started. HiRISE wasn't designed for deep space objects. It photographs Martian surface features, not fast-moving comets. No time exposure capability means limited light gathering. The team had to stack multiple images just to get that fuzzy result. But here's where things get interesting. They showed us additional images from Psyche and Lucy, different angles, different distances, different perspectives. Tom Statler made a point of explaining how valuable these multiple viewpoints are for understanding three-dimensional structure and dust properties. Absolutely true. What he didn't explain is why none of these carefully selected images showed the anti-tail structure that ground-based telescopes documented for months. So the moment finally arrived. After weeks of anticipation, NASA went live. And within the first 30 seconds, Amit Kshatriya made their position crystal clear. This object is a comet. It looks and behaves like a comet, and all evidence points to it being a comet. Firm. Definitive. Case closed. But then something interesting happened. He spent the next minute talking about how magical the universe is, how NASA actively searches for signs of life, how they just announced potential ancient life markers on Mars. Why open with that defensive posture if the science is so straightforward? The presentation rolled out exactly as you'd expect. Polished graphics, mission logos flashing across the screen. Nikki Fox proudly announced that nearly 20 mission teams coordinated observations. Hubble, James Webb, TESS, Perseverance, Maven, Lucy, Psyche, Parker Solar Probe. An unprecedented effort spanning the entire solar system. And yes, that is genuinely impressive. But here's the question nobody on that call seemed to ask. When was the last time NASA mobilized this level of resources for just a comet? We've seen two other interstellar objects pass through, Oumuamua and 2I/Borisov. Neither received this treatment. The images came next. The Mars Reconnaissance Orbiter's high-rise camera captured three I/ATLAS from 19 million miles on October 2nd. What filled the screen? A fuzzy white ball. That's what months of tracking and billions in equipment delivered, a glowing blob. Now, to be fair, the angry astronaut predicted this exact outcome before the conference even started. HiRISE wasn't designed for deep space objects. It photographs Martian surface features, not fast-moving comets. No time exposure capability means limited light gathering. The team had to stack multiple images just to get that fuzzy result. But here's where things get interesting. They showed us additional images from Psyche and Lucy, different angles, different distances, different perspectives. Tom Statler made a point of explaining how valuable these multiple viewpoints are for understanding three-dimensional structure and dust properties. Absolutely true. What he didn't explain is why none of these carefully selected images showed the anti-tail structure that ground-based telescopes documented for months. Let that sink in. This thing has survived billions of years in interstellar space. The radiation exposure alone should have processed the surface layers into inert material. Cosmic rays, temperature cycling, erosion from interstellar dust impacts, all of that should have depleted the volatile ices. Yet here it is, actively outgassing, producing substantial comas and visible tails when heated. How does an object that ancient still have pristine ice reservoirs? That's not just interesting. That's physically puzzling. Bill Harwood from CBS finally asked the question everyone watching wanted answered. Did you seriously consider this could be something other than a natural comet? Nikki Fox's response was masterful PR. She acknowledged the public speculation, praised how wonderful it was that people felt excited about the possibilities, emphasized how NASA searches for life constantly. Then came the key line. We certainly haven't seen any techno-signatures. She pivoted immediately to how exciting the differences are, precisely because this came from another solar system, then closed the door on alternative hypotheses. But what actually qualifies as a techno-signature in their analysis? Radio transmissions? Geometric structures? Because if you're only looking for alien Wi-Fi signals, you're going to miss a lot. If every anomaly gets classified as exotic comet behavior from a different stellar environment, you're not actually testing alternative explanations. You're assuming the conclusion. And those anomalies are significant. Let's talk about the non-gravitational acceleration event, because NASA mentioned orbit refinements but glossed over the magnitude. When comets outgas, the jet effect creates tiny thrust vectors that slightly alter trajectories. Predictable, measurable, usually minor adjustments. 3I/ATLAS shifted roughly 100 kilometers per day from its predicted path during perihelion. That accumulates to thousands of kilometers off a gravity-only trajectory, the largest NGA shift ever recorded. Here's what makes it stranger. Before perihelion, despite weeks of visible outgassing documented by Hubble and Webb, the trajectory showed zero deviation. Then, at perihelion, conveniently hidden behind the sun from Earth's perspective, massive spike. Post-perihelion, back to minimal deviation despite continued visible outgassing. On, off, massive adjustment. Off again. That pattern doesn't match asymmetric sublimation models. It resembles something making a deliberate course correction at the optimal moment. Maximum solar heating, maximum gravitational assist, minimum observation. Ray's astrophotography captured something else NASA didn't address. The Coma itself appears to rotate with the nucleus. That shouldn't be possible. Cometary nuclei don't have sufficient gravity to drag their expanding gas clouds into rotation. The material is actively sublimating, expanding outward, not gravitationally bound. If the nucleus is somehow dense enough to gravitationally affect its coma, then it shouldn't have been able to execute that massive trajectory shift. High-mass objects need proportionally more force for course changes. You can't simultaneously exhibit high-mass gravitational effects and low-mass maneuverability. Yet 3I/ATLAS does both. Look closely at the tail structures in the released images. NASA described them as typical comet tails pointing away from the sun, and technically that's accurate. But examine the morphology, multiple thin, parallel streams rather than a single broad fan. They resemble collimated jets more than diffuse sublimation plumes. Natural comets can have multiple jets from different active regions, absolutely. But these maintain coherence over vast distances without dispersing the way solar wind pressure should spread them. The angry astronaut called them contrails in his analysis, and it's hard to unsee that comparison once you notice it. Tom Statler used a coffee analogy to explain the differences. If you've only had Hawaiian Kona and someone gives you Sumatran, you'd expect it to taste different because it's from somewhere else. Fair point. Except the differences here aren't subtle flavor variations. Imagine that Sumatran coffee defied gravity when you poured it. Still just exotic coffee? Or time to question your assumptions about what you're actually looking at? The presentation ended with reassurances about ongoing analysis, peer review processes, and public data access. All legitimate points. Science takes time, but public data access works both ways. Independent researchers can examine the same observations, run alternative models, test hypotheses NASA won't touch in official channels. The anomalies exist in the data, not just in internet speculation. What struck me most wasn't what NASA showed. It was the resource deployment versus the conclusion. 20 mission teams, instruments pushed beyond design specs, coordinated observations spanning 5 months, archive diving to find earlier detections. Parker Solar Probe data downloaded just yesterday specifically for this object. That's not the response profile for a routine interstellar comet. That's the response when something doesn't fit the models, and you need more data to figure out what you're actually seeing. They told us it's a comet. They showed us fuzzy images and spectroscopic wiggles confirming ice and gas. And yes, those observations are consistent with cometary composition, but consistent with doesn't mean exclusively explained by. The anti-tail physics remains unresolved. The NGA spike timing looks more like propulsion than outgassing. The Coma rotation defies gravitational models. The pristine ice preservation over billions of years contradicts material science expectations. So we're left with an official answer that raises more questions than it settles, delivered with enough confidence to satisfy casual observers, but enough gaps to keep serious researchers digging. And that's exactly where the story gets interesting. So here's where we stand. NASA mobilized 20 mission teams, pushed instruments beyond their design limits, and delivered a conclusion that doesn't address the biggest anomalies. The million-mile anti-tail piercing toward the sun. Not explained. The record-breaking trajectory shift at the exact moment it passed behind the sun. Brushed aside. An object billions of years old still outgassing like it formed yesterday. Called fascinating but left unresolved. The official story is just a comet, but the data tells a more complex tale, and because NASA made those observations public, independent researchers are now digging into what the press conference didn't say. The real answers are still coming. This is exactly why Galactic Breaking News exists, to ask the questions official channels won't touch and follow the evidence wherever it leads. If this breakdown gave you a perspective you didn't see elsewhere, smash that like button and subscribe to Galactic Breaking News so you don't miss what comes next. Hit the notification bell, because when new data drops on 3I/ATLAS, we'll be the first to break it down without the PR filter. Drop a comment. Do you buy NASA's Comet conclusion, or are those anomalies too big to ignore? Let's talk about it. The conversation is just beginning.